Find the moment of inertia of a plane area shown in figure. The given figure is like this. So the dimensions are 8 centimeter. This is 4 centimeter. The height is 12 centimeter. This is 2 centimeter. This is 4. This is again 2. So these are the dimensions. You can see this is a semicircle. It's a semicircle. And we need to find the moment of inertia of this shaded portion. To find the moment of inertia, first we will fix the reference axis xx and yy. To find out the centroidal axis of the centroid of the given area. What we are going to do is we will divide this area into simple plane figures so that we can easily find out the area and its moment of inertia also about centroidal axis and the moment of inertia of the whole complex area. So for the time being, I will divide this into three plane figures. So let a full rectangle of 8 by 12, let that be 1. Then a right angle triangle 2 and 3, a semicircle. So these are the simple plane figures we have extracted from that complex area. To find out x bar, that is the centroidal axis or centroidal x coordinate of that shaded area, x bar, the equation used is a1 x1 plus a2 x2 plus a3 x3 divided by a1 plus a2 plus a3. And similarly y bar is equal to a1 y1 plus a2 y2 plus a3 y3 divided by a1 plus a2 plus a3. In this case, the third portion, the semicircular portion, is to be subtracted. So here the sign will be minus. Here also the sign will be minus. In the case of y bar also the same thing will be there. That needs to be subtracted. So let us find out all these values: a1, x1, a2, x2, a3, x3, etc. y1, y2, y3, etc. So So for the first part, which is a rectangle of 8 by 12, we have x1 equal to, what will be x1? x1 will be this will be x1. What will be x1? 4 plus 8 by 2. Isn't it? x1 is the distance from y-axis to the centroid in the horizontal direction. That will be 4 plus 8 by 2 is equal to 4 plus 4 equal to 8 centimeters from the y-axis. 8 centimeters. So this will be x1. It will be 8 centimeters. Then y1 is equal to, y1 will be, this will be y1. y1. So what will be y1? y1 will be the distance of the centroid from x-axis in the perpendicular direction. That is, y1 is equal to 12 by 2 is equal to 6 centimeters. 6 centimeters. y1. a1 is equal to 12 by 8 or 8 by 12. 12 by 8 or 8 by 12 equal to 96 centimeter square. All units are in centimeters. Similarly, x2 is equal to, what will be x2? So this will be the centroid of this right angle triangle. So x2 will be this distance. That is x2. Okay, this is x2. x2 is 4 minus 4 by 3, because we know the centroid from this portion, this line is at 1 by 3rd of the width. Width is 4 centimeter. 1/3 of the width is 4 by 3. Okay, 1/3 of the width is 4 by 3. So we need this distance only from here to here, up to here. So what we can do is, either we can find out 2 into 4 by 3 or 4 by 3 minus 4 minus 4 by 3. So 2 into 4 by 3, it will be equal to 2.67. 2.67 centimeters. It will be 2.67 centimeters. Then y2. What will be y2? y2 will be this distance. That will be y2. Which is the distance? This distance. That is this vertical distance. That is from base to centroid. y2 will be height divided by 3. That is, height is 12 by 3 equal to 4 centimeters. y2 is 4 centimeters. a2 is equal to half b into h. That should be equal to half into 4 into, when you substitute the values, it will be half into 4 into 12. So 24 centimeter square. A2 is 24 centimeter square. Then x3. What is x3? x3 is the centroidal distance of this semicircle with from y-axis. So it is same as that of the rectangle. That means it is equal to x1. That is x1 is 8 centimeters and y3 is, what will be y3? So this will be the centroid of this semicircle. So this will be y3. That means 12 minus 4r by 3 pi. I'll write it here. That is, this is y3. That is y3. So we know this distance from here to here, that is this vertical distance is 4r by 3 pi, where r is the radius of the semicircle. So this is 4r by 3 pi. So the total distance is 12. Therefore, the remaining distance will be 12 minus 4r by 3 pi. 12 minus 4r by 3 pi. So y3 is equal to 12 minus, or I'll write it here. y3 is equal to 12 minus 4r by 3 pi. And r is 2 centimeters because the diameter is 4. R is 2. Therefore, it is equal to 12 minus 4 into 2 divided by 3 into 3.1415, and it should be equal to y3 is equal to 11.15. y3 is 11.15, and I will write the a3 here. a3 is equal to pi r square by 2. That is, there is not much space. I will write it here. a3 is equal to pi r square by 2 is equal to 3.1415 into r square is 2 square into 1 by 2, and that is equal to a3 is 6.28 centimeter square. All dimensions are in centimeters. Now we have all the data for finding out the centroid. So what will be x bar? X bar will be equal to a1 x1 plus a2 x2 minus a3 x3. a1 x1, that is 96 into x1 is 8 plus a2 is 24 into x2 is 2.67 minus a3 is 6.28 into x3 is 8 divided by a1 plus a2 minus a3. So that is equal to 6.875. 6.875 centimeters. That is just after this. This will be the vertical, or vertical centroidal axis. This will be the vertical centroidal axis. So this is sorry. It is actually 8 centimeters, so it will be somewhere here. That will be the vertical centroidal axis. Vertical centroidal axis. Then y bar. Y bar is equal to a1 y1 96 into y1 is 6 plus a2 y2. a2 y2. a2 is 24 into y2 is 4 minus a3 y3. a3 is 6.28 into y3 is 11.15 divided by the same thing, 96 plus 24 minus 6.28. It will be equal to y bar is equal to 5.293. 5.293. So this is 6 just around here. So this will be G. This will be G. Its coordinates are X, from here it is 6.82875 and from here it is 5.293. That is the position of centroid. Now we have to find out the moment of inertia of this whole area. To find out the moment of inertia, what we can do is say Ixx is equal to, what is moment of inertia? Ixx equal to Ixx1 plus Ixx2 plus Ixx3, and Iyy is equal to Iyy1 plus Iyy2 plus Iyy3. This is the equation we are going to use. So in this case, Ixx3 is to be subtracted. Why? Because it is an opening. That semicircular portion is not there, therefore this must be minus, and here also it must be minus. Okay, so Ixx is equal to Ixx1 plus Ixx2 plus or minus Ixx3. This is to be subtracted in this case, and Iyy is equal to Iyy1 plus Iyy2 minus Iyy3. That will be the equation of centroidal moment of inertia. So what is Ixx1? Ixx1 is equal to moment of inertia of this rectangle with respect to centroidal axis. The centroidal axis of the complex area, whole area. So for that, I will draw this figure again so that it will be more clear. This is it. Then this is 4. This is another 4. Then x bar is 6.8, so 8. So this will be the centroidal vertical axis, and the other one is y is 5.293. So here it will be 6, so it will be somewhere here. This is G, and this is okay. Okay, now this is 1, this is 2, this is 3. Okay, now Ixx1 is equal to, what is Ixx1? So its centroidal axis is here, isn't it? So Ixx1 is equal to, using parallel axis theorem, we have a parallel axis. Ixx1 is equal to Ig plus AH square, where Ig is the centroidal moment of inertia about the horizontal axis, plus AH square is the, that means A is the area of the rectangle into H square is this distance, this vertical distance. So we know this vertical distance, that is 6 minus 5.293, isn't it? This distance is 6 minus 5.293. So Ixx1 is equal to, what is Ixx1? It is the Ig1 plus A1 H1 square. So that is equal to, Ig1 is BH cube by 12. B is, what is B? This is H. So and the height is 12. B into H cube, that is B H cube by 12 plus A1 H1 square. So that is equal to B1 H1 cubed by 12 plus A1 H1 square. That is equal to, B1 H1 cube is, I will write it here. Okay, so Ixx1 equal to B1 H1 cube by 12. B1 is 8 into H1 is 12 cube by 12 plus A1 is 8 into 12 into H1. H1 is this distance, that is 6 minus 5.295. It's square. 5.293. It was 293 actually. 293 square. So this is this distance, this particular distance. So that is equal to, Ixx1 is equal to 1199.98, or we can write 1200. That will be 1200 centimeter raised to 4. That is Ixx1. Okay. Then Ixx2 is, what will be Ixx2? That means moment of inertia of this with respect to the centroidal axis. So its centroid is at this position, we know that, and this will be the distance and the area. So let us see. It will be, Ixx2 will be equal to B H cube by 36 plus A H square. Okay. So this is equal to BH cube by B is 4. 4 into 12 cube by 36 plus A is half into 4 into 12 into the central distance will be from here to here. This will be H2 in this case. H2 in this case. Okay. H2 is this distance. What will be that distance? That is, this height is 5.293 minus this distance. This distance. That means it is 12 by 3 equal to 4. 12 by 3 equal to 4. It's square. So it will be equal to 232.12 centimeter raised to 4. Next we need to find out Ixx3. That is moment of inertia of this portion which is to be subtracted later about the centroidal horizontal axis. How to find it out? So its centroid will be somewhere here. So we need this will be h in this case as in the parallel axis theorem. So it will be, what will be its moment of inertia about its centroidal axis? It will be pi d raised to 4 by 32 plus a h square. So that is equal to pi into 2 raised to 4 divided by 32 plus area is A3. What is the value of A3? A3 was 6.283 into, what is H? H will be this distance. In this case, H will be this distance. That is from here up to here. So this distance will be, this total is 6.2 is the total. It will be 11.15. Up to here it will be 11.15. The total is 11.15 minus this thing, isn't it? So we can, how can we find out this this distance? Total minus this distance, isn't it? Or this distance. This is that was 11.15. We know y3. It will be same as y3, isn't it? Y3 and y bar minus y3, or y3 minus y bar. Y3 is 11.15. So this distance is 11.15. Okay. So it is equal to, in 6.23283 into 11.15 minus y bar is 5.29 square, and that is equal to, that will be equal to 217.27 centimeter raised to, so it is approximately equal to 217.27 centimeter raised to 4. So these are Ixx1, Ixx2 and Ixx3. Therefore, the moment of inertia of this complex area about the horizontal centroidal axis will be Ixx1 plus Ixx2 plus Ixx3, that is minus Ixx3, that is Ixx is equal to 1200 plus 232.12 minus 217.27, and that should be equal to 1214.8 centimeter raised to 4. That is I x x. Similarly, to find out I y y, we will follow the same procedure but considering the other axis. So I y y, we know I y y is equal to I y y1 plus I y y2 plus I y y3. This is the equation. We need to find out I y y1. What is I y y1? It is moment of inertia of the rectangle about y axis. About y axis. I y y1 is equal to, a rectangle is its own centroidal axis, that is IG, that is BH. So this is B and this is H in this case. Is it not? This is B, this is H. What is B? It is 12. 12 into H is 8 cube divided by 12 plus. What is the distance from centroid? The centroid the centroid of the complex area is this one. So the distance will be this thing. That is 8 plus 4, 12 minus x bar. 12 minus x bar. So area is 8 into 12 or 12 into 8 into 12 minus x bar was 6.875 square. That will be the moment of inertia of the rectangle about the centroidal vertical axis or y axis. Okay, centroidal vertical axis. So this should be equal to, what is the value of Iy1? Iy1 is equal to 633.5 centimeter raised to 4. Then Iy2, it is centroid of or moment of inertia of the right angle triangle with the respect to the centroidal vertical axis. It is equal to 12 into 4 cube divided by 36, because this is the width, this will be the height. This will be the width, this will be the height. So 12 into 4 cube by 36, that is the centroidal moment of inertia, plus area is that we have already got it as 24 or half BH. Half into B is 12 into 4, it is 24 into, what is the distance? So this will be the centroid of this right angle triangle. This is the centroid distance. So it will be x bar minus this value. X bar minus this value will give you this distance, that is h. So it will be 6.875 minus 2.67, which is x2. Its square will give you the moment of inertia. So this will be the equation for moment of inertia of the right angle triangle about the centroidal vertical axis, and it should be equal to 445.71 centimeters to 4. for 45.71 centimeter raised to 4. Now we have another one. It is IYY 3 that is to be subtracted. That we will do in the equation. Here it should be minus. IYY 3 should be subtracted because it is a that portion is not there. That must be subtracted. So for this we have the equation of uh, moment of inertia of the moment of inertia of a semicircle with this as the centroidal axis is equal to pi d raised to 4 divided by 128. Pi d raised to 4 divided by 128. So it is equal to pi d raised to 4 divided by 128 plus plus the area into x bar or x3 minus x bar. X3 minus x bar will give you this distance. We need this distance as h. So area into x3 minus x bar or x bar minus x3. If we when we square it, the minus sign will be gone. So this will be equal to pi d raised to 4 by 128 plus a into x3 minus x bar. So it is equal to pi into d is 4 raised to 4 by 128 plus area is 6.283 into x bar minus x3, that is x3 minus x bar, 8 minus 6.875 square, and that is equal to 14.235 centimeters to 4. So when I calculated Ixx3, I used the equation pi d raised to 4 by 32 by mistake, but actually moment of inertia of this circle with respect to this axis is, that is a semicircle put like this, and the moment of inertia about this axis is 0.00, I'll write it here, 0.0068, 0.0068 d raised to 4. That is the equation. 0.0068 d raised to 4. And when we calculate it, you will get the almost same value. That is why there was a small difference in the value. Okay, so 0.0068 d raised to 4. Correct it when you do this. So it is IY1 is 633, IYY2 is 445, IYY3 is 14.235. Therefore, the moment of inertia IYY is equal to 633.5 plus 445.71 minus 14.35, and that is equal to 106564.975 centimeter raised to 4. That is the answer. So Ixx is 1214.83 and IYY is 1064.975.